Hi guys, are you using a single network for everything? Your personal devices, IoT gadgets, guest devices, and even publicly exposed services? Then there might be a problem. What if one of your IoT device gets compromised? Because IoT devices are built with a focus on functionality rather than security. Even if you are not using IoT devices, then maybe someone could hack into your network through publicly exposed services. And if you don't have any publicly exposed services, what if one of your devices gets infected with a malicious app? But what about we could separate our devices into different zones? Personal devices in one separate zone, IoT gadgets into another, guest devices in their own space, and public-facing services will be isolated for safety. And guess what? We can achieve these all using VLANs. With VLANs, devices stay in their own segment, and they can't communicate with others unless you allow it. So we're going to achieve this by using our previously virtualized pfSense setup. And if you follow the same approach, you won't even need any additional hardware. However, if you're not using this exact setup or have a different networking method, you can still watch this, as you might learn something new and apply it to your own network. Even though every network is built different and should be configured as per your specific needs. If you haven't watched my previous video on pfSense, I recommend checking it out first, as we'll be using the same virtualized instance. Now, without wasting any time, let's get started. In our previous setup, we created a Linux bridge called VMBR1 while configuring pfSense. But we need to make a small change to allow multiple VLAN to communicate over the same network interface. So we will go to Proxmox and select the node. Then navigate to the Network tab and locate the VMBR1 Linux bridge. And select it. Then click on Edit, or simply double-click on it. In this pop-up window, I will remove the IPv4 address, which I have added in my last video, since pfSense does not use this setting. Now let's check the box for VLAN Aware. Then click on OK. You can also review these modifications from the Below Pending Changes section. Once reviewed, click on Apply Configuration and confirm it by selecting Yes. Now, VMBR1 should be able to manage traffic for multiple VLANs without requiring any additional bridges. Next, we need to configure pfSense. For that, I will connect to this network to access pfSense web interface. Currently, I am using VM105, which is already connected to the VMBR1 Linux bridge. To connect a VM into this network bridge, you just need to select it. Then inside the Hardware section, edit the network device. Here, we can set the bridge to VMBR1. I have already selected it. You can simply choose VMBR1 from the drop-down and click on OK. Once the VM is connected to the network, you can check its IP address to verify if the IP address is assigned from pfSense. We can easily check it from the terminal. So let's open it. If you're using Windows, you can enter the command ipconfig. And in Linux system, use the command ip-a. As I am using a Windows machine, so I will use ipconfig. This is the IP address, and it has been assigned by pfSense. Now we should be able to access the pfSense web interface to create the VLAN. So I will open a browser and enter the IP address 10.17.13.1. If you have forgotten the IP address of your pfSense login page, you can use a trick. Simply copy the IP assigned to the VM and replace the last number with 1. For example, my VM's IP is 10.17.13.10, then pfSense can be accessed at 10.17.13.1. Once we are able to access pfSense login page, let's quickly log in. First, we need to navigate to Interfaces in the pfSense menu. Then select Assignments from the drop-down. From here, I will go to the VLANs tab and click on Add to create a new VLAN. This is where we can set up the VLAN settings. For the parent interface, I will change the interface from WAN to LAN. This ensures that the VLAN operates within the internal network. Then let's assign a VLAN tag. For this setup, I will set it to 3. This will help us to isolate and manage network traffic within the LAN, ensuring the devices are grouped into a specific VLAN. And we can provide a description here to identify this VLAN easily. I will enter VLAN 3. Once done, we need to click on the Save button to apply the changes. Now let's assign an interface for my VLAN. To do that, I will navigate to the Interface Assignments tab. Here, I can see that VLAN 3 is already listed as available network ports. So I will click on this Add button to create an interface for it. Once added, pfSense will automatically name this interface as OPT1. Let's click on this OPT1 to configure it. First, I will check the box for Enable Interface to activate it, and enter a description to make it easily identifiable. I will provide VLAN 3. Then, I will set the IPv4 configuration type to static IPv4. Under static IPv4 configuration, I will assign the IPv4 address as 10.17.3.1 and set the subnet mask to /24. You can use any other IP address, just make sure it ends with 1. Once done, we can click on Save. Then apply the changes by clicking on the Apply Changes button. Now, if we go back to Assignments under the Interfaces menu, we should be able to see the newly added VLAN 3 interface listed here. After setting up the interface, we need a DHCP server which can assign IP addresses to the devices on my VLAN. For that, we need to navigate to Services and select DHCP server from the drop-down. Before setting up the DHCP server, you can see there's a warning at the top of the page indicating that the ISC DHCP server has reached its end of life. By default, pfSense uses the ISC DHCP server, but since it is no longer supported, let's see how we can modify the DHCP server backend. For that, I will go to System and select Advanced. Then, I will click on the Networking tab. Here, I can see the DHCP server backend option. We can select Kia DHCP from the options and click on Save to apply the changes. Now let's verify if the change is successful. So I will navigate back to Services, then open DHCP Server. We can see that the warning is no longer visible. Now we can configure the DHCP server for VLAN 3. So I will click on the VLAN 3 tab. On this page, I will check this box to enable the DHCP server on the VLAN 3 interface. Next, let's set the primary address pool range. For the start address, I will use 10.17.3.100. For the end address, I will use 10.17.3.200. The DHCP server will assign addresses between this range, and there will be enough available IP addresses for static assignments. Once done, I will click on the Save button, and then Apply Changes. As we have modified the DHCP server, we will have to restart it. So I will navigate to the Status and select Services from this drop-down. In this list, we need to find Kia DHCP4 and click on the Start button. This should restart our DHCP server. Now let's create a new virtual machine for this VLAN 3 network. So I will navigate to Proxmox and right-click on the Ubuntu server template, then select Clone. Let's set the VM ID to 401 and give it a name. I will name it as VLAN. Then click on the Clone button. Now that the VM is created, let's configure its network settings. For that, I will select the VM, and inside the hardware section, I will double-click on the network device to modify it. Let's change the bridge to VMBR1, but I will not provide any VLAN tag for now, because there will be no internet connection inside the VLAN as per the current configuration. However, we need to update the system and install a package before testing the VLAN. Once done, click on OK. Now let's start the VM. I will quickly log into it. If we go to the Summary tab, we can see an IP address has been assigned from the pfSense LAN subnet range. If you're not using the QEMU guest agent and the IP details is not visible here, you can also check it from the terminal. So let's quickly prepare this VM. I will open the Console tab and update the system by running the command sudo apt update and sudo apt upgrade. Once the update is complete, I will install a package by typing sudo apt install iputilsping. This tool will help us to test our VLAN connections. Now let's assign the VLAN tag to the VM. I will go back to the hardware section and edit the network device. Here, we need to set the VLAN tag to 3, and then click on the OK button. Now if I go back to the Summary tab, we can see that the IP address is from the VLAN 3 range. If the VLAN 3 IP is not assigned for your case, then try restarting pfSense, as this can often resolve DHCP-related issues. Now it's time to test if we can ping this VM from outside of the VLAN. I will open PowerShell on the host machine and check if the Ubuntu VM is reachable. To do that, I will ping the Ubuntu VM. And this response confirms that the VM is accessible from the host machine. It means we can access devices inside VLAN from outside. Next, I will open the console for the Ubuntu VM and check if it has internet access. So let's ping Google. But the connection is unsuccessful, which means this VM can't reach the internet. Now I will verify if the VM can communicate with other devices outside of the VLAN. For that, I will ping my Windows host machine, but this is also unsuccessful. Now I will also try to ping the Proxmox host, which is in my actual home network on the WAN side of my pfSense. But the VM is unable to establish a connection. So the VM inside the VLAN is currently isolated from both the local network and the internet. But this is not what we want. So we will create firewall rule for this VLAN. To do that, I will open pfSense and navigate to the firewall section. Then select rules from this drop-down. By default, the WAN tab will open, as I'm going to create rule for my VLAN 3 network, so I will click on the VLAN 3 tab. This interface does not have any rules yet, so let's create one. I will click on the Add button to create a new rule. For this rule, I want to set the protocol to any. Then I will define the source as the VLAN 3 subnet. The destination will remain as any. This ensures any traffic coming from VLAN 3 is source, and trying to reach any destination will be allowed. Now to create, I will click on Save. Then Apply Changes. To test this, I will open the console for the Ubuntu VM in Proxmox. And I will again ping Google. Now we are able to get a response, means we have internet access. Next, I will check if the VM can communicate with the Proxmox server. We are able to get response from Proxmox as well. Now I will try to ping my Windows host machine. We are not able to get a response, which is unexpected. This might be because my Windows machine got a new IP after switching the DHCP server backend. Instead, let's ping pfSense to check if we can establish a connection with the LAN network. And we are getting a response. But our goal is to grant VLAN 3 internet access, while restricting it from accessing other devices on the network, including the home network on the WAN. For that, let's open pfSense and navigate to Firewall. Then select Aliases. Now let's click on the Add button to create a new alias. Here, we need to provide a name to use it as alias. I will name it as MyPiece. And I will change the type to Networks. Under Networks, I will add the first entry by specifying the network as 10.0.0.0 and setting the subnet to /8. I want to add another network. For that, I will click on this Add Network button. This time, I will set the network to 192.168.0.0 and the subnet to /16. Once done, I will click on Save and then Apply Changes. Now you can see that these two IP ranges are grouped under the alias MyIPs. The 10.0.0.0/8 network is used for my pfSense network, while the 192.168.0.0/16 network is reserved for local devices on my home network. This alias will make it easier to manage access control and firewall rules. Next, I will update the existing VLAN 3 firewall rule to restrict access to the IP addresses inside the alias, while allowing all other network traffic. To do that, I will navigate to Firewall and go to Rules. Then select the VLAN 3 tab. Now I will click on the Edit button to modify its settings. On this page, first I will change the destination to address an alias. In the destination address field, I will type my IPs and select it from the suggestions. Next, I will check the box for Invert Match. This will ensure that all traffic is allowed, except for the IP addresses listed in the MyIPs alias. Now I will click on Save and then Apply Changes. Let's navigate to Proxmox and open Console. Here, first I will ping Proxmox. As you can see, the request does not reach the destination. Next, I will try to ping pfSense. And again, the request is blocked. Finally, I will test internet access by pinging Google. But we are unable to access it. However, we should be able to access anything outside of the local IP ranges. This is happening because the DNS request failed. Since DNS queries are resolved by pfSense, we are not able to access the internet. To fix this, we need to create an additional rule to allow DNS traffic. For that, I will open pfSense, and under Firewall Rules section, I will add a new firewall rule. Here, I will set the protocol to TCP/UDP, as DNS traffic operates over these protocols. Then, I will change the source to VLAN 3 subnets, ensuring that this rule applies to all devices within VLAN 3. For the destination, I will select VLAN 3 address. In the destination port range, I will choose DNS, which corresponds to port 53. This will allow VLAN 3 devices to send DNS queries to pfSense. Once everything is set, I will click on Save. Make sure that the firewall rules are in the correct order, as the sequence can impact how they function. In pfSense, rules are processed from top to bottom, meaning the first matching rule takes effect. To adjust the order, you can simply drag and reorder the rules as needed. Any traffic attempting to access DNS will be allowed by the first rule. If the traffic is not a DNS request, it will move to the next rule for evaluation. This ensures that DNS queries are processed correctly, while other network traffic follows the intended restrictions. Then I will click on Apply Changes. Now, if we go back to Proxmox, and inside Ubuntu console, ping Google, we are able to get a response. Next, I will try to ping Proxmox. And as expected, there's no response. Similarly, I will ping pfSense. And again, there's no response. So our firewall rules are working as expected. Now I will switch to a Windows machine and open PowerShell. Here, I will ping the Ubuntu VM. We are able to get a response from outside the VLAN. Now you can see that devices outside the VLAN can reach it, but anything inside VLAN only has internet access and cannot communicate with other devices on the network. And that's it. Now we can create as many VLANs as we want. And we can apply the firewall rules as required. If you like this video, you'll probably enjoy the next one on securing your network.